Okay, here we are looking at the third checkpoint. This is, let's say, a particular checkpoint. It's a checkpoint that you need just to load the best available pixel repository on your Google Engine account. So if you use this link, if you have a Google Engine account, you will see a new repository appearing in your, not writer section, but in your reader section, you will see a new repository appearing with the name BAP. That is the repository I have here. So using this link, you can access the best available pixel composite code and user interface. I'll show you very soon how the best available pixel user interface works, but wanted to show you just very quickly the fourth checkpoint. So the fourth checkpoint is, I suggest you to have a look at that, because it is a very simple way and also a very useful way, let's say, to use the best available pixel composite code, and so to construct composites that are very, let's say, scientifically rigorous, and that you can use also for scientific publications. So here, what we are doing is defining some parameters that are needed to construct the best available pixel composite. Just a little bit of background. So now we will see together at those arguments and very quickly at this code that is very simple actually. And then we will see the user interface that allows you to define those parameters easily. Okay. So using just buttons or text boxes or sliders or so on. But what is the best available pixel? So the best available pixel is an algorithm that uses Landsat 5, 7, and 8 so far for constructing pixel-based composites. Very soon, we'll implement also the Landsat 9 collection. The best available pixel composite is selecting from an image collection the pixels that are, let's say, the best on the basis of some criteria. So those criteria are the distance from clouds, the day of acquisition, the opacity, and using those criteria for each pixel, what the BAP does is to try to pick the pixel from the image in which it had better surface reflectance values. So here we are defining those parameters that are the parameters used by the best available pixel composite. We can see them again very soon. Then we are, as before, defining the study area, and then we are requiring the BAP library. So once you have the BAP library on your Google Engine account, what you can do is to use this require function that allows you to get the functions that are included in this file. So users Francini BAP library is actually this file that is stored on my account. And then here, library.bap. So you're saying that I want to use a function that is in the library object, and the name of this function is BAP. Then what you're doing is defining the arguments to apply this function. In this case, are the arguments we defined at the beginning of the study area. Then here we are applying an additional quite complex operation, that is the spiking algorithm. So here we are trying to remove, let's click run in the meantime, because this function can take a while. Let's start to visualize just an image. Here we are despiking the collection. So here we are applying another function that is again available in the library, so in this script. And this function is used to remove remaining clouds from composites. These functions require some parameters. We have the spike threshold, the number of bands, the composite, the period over which we want to apply it, and then we have a value that you can use if you want to have additional bands in the output, but you don't need this very often. The despiking algorithm actually studies the photosynthetic activity over the whole time period and tries to detect spikes in that time series. And the spikes are the clouds that were not correctly masked out, or the shadows, again, that were not correctly masked out. So what we are doing then, we are obtaining a BAP collection, image collection, from which noise was masked out. And then we are finally using another operation that is the infilling algorithm. This algorithm, using a linear interpolation on the basis of the time series for each pixel, tries to fill the pixels in which any valid observation was available over that year, or pixels that were removed, that were masked out using the despiking algorithm. So this is, let's say, one of the state-of-the-art procedure that you can use to obtain proper yearly composites or monthly composites over a study area. You can see that there are still some white pixels because, yeah, again, this is a very cloudy region. What we are doing here is to centering as before the map over our study area. And then this is an interesting stuff because you can see that we are not using as before the map.addLayer function, but to visualize the image, but we are using a function that is in the library and that can be used to apply an image collection and not the whole time series. Here, and indeed here you're defining the start here and then and the end here, that were the 2015 and 2017. And finally, you are adding a slider, still using the library, adding a slider that is this object that allows you to visualize the different images. You cannot do that because I calculated just the 2016 one, but hopefully also the 2017 will appear soon. Or not. Yeah, okay. As you can see, using the slider, you are able to see the two images. So have a look at the VIP, and then for my side, we are done. The VIP repository that you'll get using the link available on the book will provide you with two files, with two scripts. The library one, that is that one that includes all the codes, all the functions, and so on. And here you can, of course, find several functions to mask out clouds. For example, I forgot to mention that, but here you can find some of them. And here we have the user interface code. This is the code that is instead used to construct the user interface. If you open this file and you click run, you'll see this window appearing. And what this window does is allowing you to define the parameters that we have seen in the previous script. The start here, the end here. There are different options for defining the study area. For example, you can draw a very small study area, for example, in Italy, this country. Then you can decide if you want or not to load images. You can define the study period, the time period to construct the composites. In this case, you are constructing composites using images acquired in July and August. The clouds mask, some additional parameters for constructing composites, for which you can find details using this link that will open. Okay, I have that will open a new link here. Okay, that will open a new link, and here you can find the documentation for the best available pixel composite. And yes, and then you can click run. If you click run, the composite will be calculated over the study area. There are also advanced parameters, so you can also apply the despacking algorithm. That is the algorithm we have seen before. You can infill data gaps as we detailed before, using a linear interpolation of the time series. You can calculate spectral indices. Here we have some of them, but you can calculate more indices using your own operations. And then here you can run the composite and reset the composite. As you can see here, we have the VAP that can be often calculated over larger regions. Just wanted to show you the differences that you can see between the default best available pixel composite and that is obtained by using the despacking algorithm here. Okay, in Italy we don't have a lot of clouds actually, but we can use the despacking algorithm, and hopefully we will see that some of those white pixels will become black, so will be removed by the despacking algorithm. So they will be detected as spikes in the time series in the time series using this threshold, and to be removed they have to be detected as spikes in at least 3 bands. That is an additional threshold that you can set. As you can see here, we have 3, 4, 5, 6. That is the number of Landsat bands. And indeed, we have masked out a lot of clouds. They were white, now they are black, and they were thus removed from the image collection. The very, very final step is to infill data gaps. And using this step, hopefully, we will get good values also for those pixels that were previously detected as spikes. This is very important when you want to use pixel-based composites for providing statistics across large areas, or for providing country-wide statistics. It is very important to have good data over the whole study area, and also it is very important to have valid observations for each pixel. So as you can see, we are getting values also for pixels that were black before. Now we have valid observations. And just one last slide, we are organizing in Florence a Cooler Engine summer school. Please follow me if you want to have more details. This is here. It will be the 3rd edition, probably at the beginning of September. So if you are interested in learning more outcomes also from this book, please follow me, and I'll try to keep you updated. Thank you very much for the attention.